Welcome to my Lab 4, the physics of extreme sports with ropes.
So after I imported the video into Tracker, I used the point mass tool to track where the position of the ball was throughout the time frame. I also made sure to put a calibration stick to know from the point of reference down to the point center of mass to be 7 meters. And then the point of reference is right here. And then after you're done measuring that, this is the positive y direction and this is the negative y direction, positive x, negative x. And you can see how it oscillated about close to 6 times. And after that, I took the data, the x and the y, and I transported it into a CSV file, which I will show you right now. I had a hard time trying to get that into it, but eventually I figured it out. So I select all like this. I hit copy as formatted. Then I go into my Google Drive, type in a spreadsheet, and then I paste it into the file. And then I also deleted the first 2 rows because you don't need those. After that, to save this into a CSV file, just go to File, Download as CSV file. And then make sure you save the name as in your program, so the Python can actually find it. So now we are going to go into Python. At the beginning, the system properties, I define the ball, the mass of the ball position, and the ball vector. And then afterwards, I inputted my CSV file from Tracker that I made into a file at the beginning when I first showed you. So in the other initialization, the delta t time is kept small. And then this is the basic, the gravitational force near the Earth's surface, 9.8. The spring constant, the relaxed length of the spring, and then the length is the position of the ball minus the position of the spring. And then these are to compute the system energy. Here we are defining the initial energy. And then this is how we found the gravitational force. And then the spring force unmasked by the spring, the net force. And these are where we update the spring and then change the energy changes. So now for what does it mean? In my model system, the energy principle is satisfied because all of the energy eventually balances out.
I mean that eventually the forces, the kinetic energy and the potential energy eventually, they will actually cancel each other out.
And in the model, in the data, the 2 period of oscillation, so I'll show you. So with Y, you can see that if it's compared with X, is lower in the Y-axis, probably because it started lower, and the period oscillation is about the same for them, not completely 6. If you put the X oscillation period and the y oscillation period into Python, you will find that the y will be more accurate. Also, the computer model versus the tracker model that we use, not exactly the same all through the time period, because first of human error, and also when we look at this, we're just doing with our naked eye, and also some part of the spring mass is actually moving in the z direction, but tracker doesn't allow that option. So you put it into your code, you can actually run it to see. It's the same for the most part.
Thank you for watching.